Electrochemistry. Class 12, one of the very important physical chemistry chapter is electrochemistry. In electrochemistry, we actually deal with two types of things. One is conversion of chemical energy into electrical energy. Chemical energy into electrical energy. Second is conversion of electrical energy into chemical energy. Chemical energy. Fine. Right. So can you give me some examples for this? Chemical energy into electrical energy is batteries. Okay, na? We know about the batteries which we use in remote control. Okay, na? All these pencil batteries, that double A size, triple A size batteries will be there. Na? All those, they are utilizing chemical energy to convert into electrical energy. Second is electrical energy into chemical energy, utilizing electric power to produce some compounds like extraction of metals and all. So one by one we'll take. First we'll see chemical energy into electrical energy. This part we will discuss today. So for this purpose, we discuss actually one cell, okay, na? Daniel cell, or you can call this as galvanic cell, or you can call this as voltaic cell. Okay, Daniel cell or galvanic cell or voltaic cell. Actually, what happens in this cell is, by a chemical reaction, we are going to produce electricity, and the chemical reaction is zinc copper sulfate reacts with reaction takes place and forms zinc sulfate and copper. Zinc plus copper sulfate gives rise to zinc sulfate and copper, where zinc oxidation state changes from 0 to +2. So this is oxidation. Zinc undergoes oxidation. Copper +2 to copper 0. This is reduction. Means the overall reaction is going to be redox reaction. Reduction as well as oxidation both are taking place. So it is a redox reaction. Daniel cell or galvanic cell or voltaic cell, all these cells, okay, now all these cells, they have a redox reaction in which one component undergoes oxidation and another undergoes reduction. The one which undergoes oxidation is called a reducing agent or reductant, you can say, and the one which undergoes reduction is oxidizing agent. Fine. So how it is going to be? First take a container, fill this with zinc sulfate solution. This is zinc sulfate solution, and keep here a rod, zinc rod. When you keep zinc rod in zinc sulfate solution, you can call this as single electrode. Zinc in zinc rod is single electrode. Similarly, you take one more container. In this, take copper sulfate solution. If you want, keep your blue color solution because copper sulfate solution is blue in color, correct? And keep here copper rod, copper sulfate solution and copper rod. When copper rod is kept in copper sulfate solution, this is again a single electrode. So here you are using two single electrodes. One is zinc rod dipped in zinc sulfate solution, another is copper rod dipped in copper sulfate solution. These two are connected externally and are connected internally by a U-shaped tube which we call salt bridge. This salt bridge contains KCl, ammonium chloride type of salts with a gel called agar gel or agar-agar gel. What is the role of salt bridge? Salt bridge role is to stop, okay, now to stop accumulation of ions. I will tell you this in detail. Just you remember this, I will tell you again. Accumulation of ions is stopped by the agar-agar gel, KCl, NH4Cl, which we are calling as salt bridge. What actually happens here? Look into the diagram carefully. This is zinc rod in zinc sulfate. And this particular zinc side is called anode, which is given with a negative sign here. Copper side is cathode, which is with the positive side. In general, cathode is negative and anode is positive. But in cells, it is reverse. Cathode is positive and anode is negative. Okay, now that part we'll discuss later in the second part. Okay, now where cathode is negative, anode is positive. But here it is anode negative, cathode positive. Why anode is negative? That part also I am going to give you in detail. When you are taking a zinc rod in zinc sulfate solution, this zinc rod, it loses electrons and becomes Zn plus 2, and the electrons are going to be accumulated here. So many electrons coming from zinc are going to be accumulated here. Because of that, it is given with negative side. And this is oxidation. Oxidation takes place at anode, so this is called anode. This particular is called anode and it is shown with negative sign because electrons are there. Zinc is becoming zinc plus 2 means zinc plus 2 ions are going to be forming here. That means zinc plus 2 is coming into this. Okay. Now, when zinc plus 2 ions are coming into this and electrons are there, okay, now zinc is only becoming like zinc plus 2. Electrons are coming out and the electrons are here. Now the electrons are going towards the copper, but before that, the formed zinc plus 2 ions, there is a possibility of going again toward the electrode because electrons are there. Zinc plus 2 may be attracted that side or can be attracted that side. To stop this movement towards the electrode, we have salt bridge. As we know, salt bridge contains KCl, NH4Cl, all these. So K plus ions are there, Cl minus ions are there, NH4 ions are there, Cl minus ions are there. All the cations are attracted towards these anions. Means when you have this type of salt bridge, let us say this is zinc rod, this is copper rod, and this is salt bridge. I am showing little bigger here. Zinc plus 2 ions are coming here. Here Cl minus ions will be there. All these are attracting zinc plus 2 here. Got it? So zinc plus 2 ions should not go here. That's why we are attracting zinc plus 2 here by utilizing these chloride ions. This is the role of salt bridge. Stopping accumulation of ions. Clear? Chalo. So zinc is losing electrons and the electrons are coming here. All the electrons are moving like this. So electrons will be flowing from moving external circuit from anode to cathode, that is zinc to copper. Electrons flow is there, and when electrons are flowing like this, current flows in this way. Current flow and electrons flow are exactly opposite. Zinc to copper, electrons flow. Copper to zinc, current flow. Okay, now remember this point very clearly. And in this process overall, the voltage we are getting is 1.1 voltage. So what happens with copper? Now you are talking about copper. Here copper rod is there and this is copper sulfate solution. And from zinc rod, the electrons are coming and reaching copper rod. This is what we are calling second electrode. Now copper sulfate solution contains Cu plus 2 ions. All the Cu plus 2 ions are accumulated here by gaining electrons from here. Cu plus 2 electrons gives rise to copper. So copper is going to be accumulating here. So this copper rod becomes Mo2. Copper rod becomes thick because of addition of extra copper. And when copper loses sulfate ions, okay, now these sulfate ions must be neutralized or sulfate ions must be stabilized there. For that purpose, again we have salt bridge. In salt bridge, whatever the cations are there, like K plus and NH4 plus, they are attracting these sulfate ions. Got it? Salt bridge role is to stop the accumulation. Now copper are here, right? So this is the overall process. Current flow is from copper to zinc. Electron flow is from zinc to copper. Overall, the voltage is going to be 1.1 voltage, and zinc rod is here, copper rod is here. Zinc is undergoing oxidation to form zinc plus 2, copper plus 2 is becoming copper. So this rod becomes thin, this rod becomes thick. Okay, later. This is shown with a chemical reaction is zinc plus copper sulfate gives rise to zinc sulfate plus copper. This is the redox reaction. You can show this Zn by Zn sulfate two lines copper sulfate by copper. This is one electrode, this is another electrode, this is left hand side, this is right hand side. Here oxidation takes place. Left hand side is always oxidation, and right hand side is always reduction. So you can say zinc is becoming zinc plus 2, and here copper plus 2 is becoming copper, like this. Okay, not every time like this. Generally we show metals always outside. Okay, now metals always outside. Zinc undergoes oxidation here, copper sulfate, copper plus 2 is undergoing reduction. Okay, for this generally reduction potential values also will be given. Potential for the reduction purpose, whatever the energy required, that value will be given to you in the question. Reduction potential values. For this particular example purpose, I can remember this value Zn plus 2 by Zn. See here carefully, zinc plus 2 by zinc means it is reduction potential, and E naught means standard. Standard means normal condition, like 1 atmosphere pressure, 1 molar concentration, regular condition. Standard reduction potential value is minus 0.74 voltage, 76 sorry, minus 0.76 voltage. And for copper it is going to be Cu plus 2 by Cu. This is also reduction potential only. This is also reduction potential. Both are reduction potentials only. We need to take reduction potentials only. You will be given reduction potentials only. Okay, now. So that is going to be plus 0.34 voltage. Got it? What is our cell? Zn by Zn plus 2, copper plus 2 by copper. Like this also you can write. Zn by zinc sulfate, copper sulfate by copper. Like this also you can write. And when reduction potentials are given, sir, you can ask me, sir, here it is undergoing oxidation, now why you are taking, that is the formula beta, that is the formula. When reduction potentials we are going to use, then E naught cell is equal to right hand side minus left hand side. Right hand side is copper, copper value is 0.36, left hand side is zinc, zinc value is minus 0.74, 76 na 7634, whatever is the values, let us check the value. Okay, so this is going to be 1.1 voltage. Got it? So when you are taking 1 molar zinc sulfate solution, 1 molar copper sulfate solution, and it is in the presence of zinc, this is in the presence of copper, and when you are collecting, you are getting there 1.1 voltage. See, this is salt bridge, this is zinc rod, this is copper rod. At copper rod, copper plus 2 is gaining electrons to form copper. At zinc rod, zinc is losing electrons to form Zn plus 2. Electrons are flowing like this, current is flowing like this. This is the salt bridge. This is zinc sulfate solution, this is copper sulfate solution. Perfect. Now let us see, here ammeter will be there. If we are connecting this to an electrical external energy, and if energy, for example, in this case we are saying 1.1 voltage is coming, that voltage you need to take now, so we will be getting that energy. But if you are having external energy more than 1.1, okay, now if external energy is more than 1.1, then what happens? See, this is zinc, this is copper, this is zinc sulfate, this is copper sulfate, everything is same. External connected, okay, now salt bridge, everything. Now electrons will flow like this, and current flows like this. Exactly reverse. Okay, if the external energy is more than 1.1, it is like just remember your mobile phone charging. Okay, now we know about mobile phones and all. Mobile phones contains lithium ion battery. Okay, now very similar type of thing you can say. When you are not charging, when you are using phone, electrical energy is converting into chemical energy. Chemical energy is converting into electrical energy. When you are charging, okay, now charging means the mobile phone battery, whatever the voltage is there, more than that voltage you are giving from outside. When you are giving from outside, here the reverse reaction takes place. Mobile is getting charged. When the external energy is not there, external power is not there, then mobile phone is utilizing its battery. If external power is there, it is getting charged. When external power is not there, it is getting utilized. Very similar concept. Now you can ask if the value is exactly 1.1 voltage. No electrons flow, no current flow. Nothing will happen. So less than 1.1 voltage, if external energy is there, the electrons will be flowing from zinc to copper. If external energy is more than 1.1, then copper to zinc electrons flow will be there, and current flow is always opposite. Okay. So I told you the formula RHS minus LHS. Okay, now when you are using SRP only, SRP means standard reduction potential. No, not like that. I want to use whatever the concept is there, means you can do better. That is not a problem. Remember, zinc side, copper side. Here oxidation taking place. Here reduction taking place. So if you want E0 cell, then zinc oxidation potential you need to take, and copper reduction potential you need to take. Got it? And E0 zinc plus 2 by zinc, if it is minus 0.76 voltage, see carefully, E0 Zn by Zn plus 2 will be plus 0.76 voltage. Zinc plus 2 to zinc means you are talking about reduction. Zinc to zinc plus 2 means you are talking about oxidation. This is oxidation potential, this is reduction potential. You see oxidation potential is 0.76 and reduction potential is 0.34, so that is again 1.1 voltage. Okay, if you are using reduction potentials only, RHS minus LHS. No, I want to use the concept, means yes, left hand side oxidation is taking place, right? So oxidation potential value you take, right hand side reduction is taking place, so reduction potential value you take, add them. Okay, got it? So more things we'll discuss in coming time. Thank you so much.